Okay, I'm going to take a look at practice problem 4, still to page 238. Okay, this is a hydraulic fluid is compressed by a piston in a cylinder, producing a change in pressure. Okay, before the piston's activated, the hydraulic fluid fills 20 centimeters length of the cylinder. Okay, um, so what happens is it gets compressed, and then the length changes. So it basically loses, it's not 20 centimeters anymore. It's 20 minus 6.5 millimeters. Okay. Um, this one basically tells you the original volume. You can use this information to come up with the original volume. And this one, you can use this to give you the change in volume, essentially. Okay. So we're looking for the bulk, we're looking to calculate the bulk modulus of this fluid, right? Um, Bulk modulus, of course, is related to the compressibility of fluid. Okay, so looking for K. K is the symbol typically used for bulk modulus. All right, so we have a change in pressure, 40 megapascals, which is basically 40 times 10 to the 6 pascals. And if you remember, Pascal is just a Newton per meter squared, okay? So what we can recognize here from that is that we need to, and in fact, it actually really doesn't matter any units we use here, it's just as long as these two match each other. But we'll convert over to meters, okay? So I just took this 20 centimeters, and of course 20 centimeters is just 0.2 meters because there's 100 centimeters in a meter. And then millimeters, 1,000 millimeters in a meter. So um, this one just comes to be 6.5 times 10 to the minus 3 meters. Okay, so I made those conversions directly up to start. All right, governing equations. First, we know we need bulk modulus equation, right? So it has delta P and it's delta V over V. Okay. Okay. So we recognize right from this that we're given delta P, but we're only given quantities that can help us find delta V and V, right? Right. So we also need to figure out what the volume is. So we look at the shape, right? So the shape is a cylinder. So it's just going to be pi r squared times the length. That gives us the volume. This is the equation for the volume, right? And what do you think? This is the cross-sectional area portion times the length gives us the volume. Okay? All right. So the solution. First, we're going to solve for delta V over V. And what you recognize, right off the bat is like, well, let's see. I don't know what R is here, right? But we're going to go and set up the equation, and you'll see what happens. Okay. So delta V is just equal to essentially pi r squared, the radius squared, times delta L, which is the change in length. Okay. And then V, of course, is pi r squared L. Okay. Same thing. So now what you have is you have a ratio here, delta V over V. It's going to be negative, okay, in this case, because the change is negative, right? So I wrote it as this. Maybe I could have just written it as, it's a negative change. So I put the negative over here because I just wrote the equation like this. But what do you recognize is that this is a negative delta V, right? Because our volume is actually decreased. Okay. So what you notice is from that is that pi r squared cancels out for both of them in the numerator and the denominator. So you have minus delta L over L. So you just put the negative 6.5 here. So either case, if you wrote it as, delta L or negative delta L, you could have made it negative 6.5 millimeters. I chose to put it down here when I did the calculation here. So the number comes out to be minus 3.25 times, which is just a ratio, minus 3.25 times 10 to the minus 2. Okay. Then you go and solve. So you put this is negative and this is negative, so then you have a positive come out, which is just 1.23 times 10 to the 9 pascals, or 1.23 gigapascals. Okay. Yeah, the part that you have to recognize here is that this, I put it as an absolute value at the top, but this is it's a negative, right? So delta L is actually a negative volume. I wrote it as like this, but um, since I wrote it as delta L is just a absolute value here. Okay. All right. So that's the solution for this problem.